Hello students and welcome to Sourav's classes. The first question in this video, I will be solving many questions, around 16 questions I will be solving. The first question is on a sequence, and this is a sequence of real numbers given by Sn equal to sine of pi by 2, 1 into 2. So you can see a pattern 1, 2, 2, 3, n into n plus 1 is the common pattern. Now we have to decide whether it is convergent, divergent, oscillatory sequence or Cauchy. In order to solve this question, we can proceed in the following way. First of all, we can derive, or we can write from this particular sequence that Sn equal to summation of sine of pi by 2 to the power n, this is increasing, and n into n plus 1. Simplify the last term, utilizing this last term, we can write it like this. So this is n equal to 1 to n. Okay, this is the basic structure. Now limit n tends to infinity Sn, if we write, so here also the same thing will happen. So summation, there will be a slight changes, pi by 2 to the power n by pi by 2 to the power n, just in order to match the sine pattern I am doing it, and then sine 2 to the power n will be multiplied, and this n plus n by 1 will be here. So obviously this particular thing can be rewritten as limit of n tends to infinity pi by 2 to the power n into n plus 1. That's it. So this is, if we put infinity, so this is 1 by infinity, so this one is 0. Hence, as this part is converging to a particular part, so this must be a convergent sequence, and we know that every convergent sequence is a Cauchy sequence. So convergent, hence it is Cauchy. So first sum, option is D. Now we are proceeding to our second sum in this question paper. So in the second question is, let P be the vector space. So this one is on a vector space. Now it's a vector space and the polynomials of less than equal to 3. So this is the important information. It is less than equal to 3 and all the coefficients are here real coefficient. So we need to consider this particular function, and with respect to Matrix representation, which one satisfies the given structure. So here we need to do it that T is 0, a1x, a2x square, a3x cube. This thing is given as a3 plus a2x plus a1x square plus a0x cube. Okay, so let beta equal to 1x x square and x to the power 3. Okay, and beta, this is the ordered pair of p over r. So this is the ordered pair of p over r. So clearly T of 1, which we can write T of simply 1 plus 0 into x plus 0x square plus 0 into x cube. So that is this particular pattern. So 0 plus 0 dot x is 0 dot x square, 1 dot x cube. Similarly T of x will be T of 0, 1 dot x, 0 into x square, 0 into x cube. So T into 0 will be 0, then 0x, 1x square and 0x cube. Okay. Now in the third part of this question, that is T of x square, we can do it in the same way. We can proceed. See, the approach of this kind of questions is immensely important. If you get it in the very first go, you will be the winner. So in that way you can also find T of x cube, and we can form that matrix, that is T of beta. This will look like the coefficient 0, 0, 0, 1, 0, 0, 0, 1, and here it is 0 0 1 0 0 1 double 0 and 1 triple 0. Okay, so now we need to find m square. You can find it very easily. So you can see that m square will be coming 1 0 0 0 0 1 0 0 0 0 0 0 1 0 and triple 0 1. So this is a I4. So we can directly write m square equal to I4. So with respect to the option, which one is matching? Yes, option B is only matching, that is m square minus I4 equal to 0. So all you have to find is the matrix representation and then proceed with the analytical part, and all you have to do is to put these values over here. Okay, that's it. Now we are proceeding to third question. In the third question, they have given an integration of a continuous function and they have asked to find 0 to pi x of f of sine x. So how to do this? So here I equal to, I can write 0 to pi x of f of sine x dx. In the very next line, utilizing the formula 0 to pi minus x f of sine of pi minus x. This is dx. Okay, so this can finally be written as 0 to pi minus x f of sine x dx. Let this be 1 and let this be 2. So adding 1 and 2 we will get, so 1 plus 2. What we get? 2i. So 2i equal to 0 to pi plus x minus x f of sine x and dx. So similarly you can just write it as pi by 2, pi will be out of the system, x will cancel out. So pi by 2, 0 to pi, and this will be f of sine x dx. That's it. So you can put it in the function and you can see that option A is the correct answer. Okay. Now we are proceeding to our next question. This question is about a very important idea. Let sigma be an element of the permutation group S5. Okay. So S5, then the maximum possible order. So remember that if the permutation which is given by sigma is of that, we know that permutation sigma in Sn has a maximum order. In Sn has a max order equal to n itself. So if the permutation is of group S5, so max order is also 5. So in this case, A is our option. So this one is a relatively easier one compared to the other ones which we have done. Okay, now let's proceed to the next question. This question is about a strictly monotonic continuous real valued function. This is the main thing. Monotonic function means f of x plus n greater than fx, and this kind of pattern is always applicable. So if it is increasing, so when the entire function is always proceeding to a same direction, then we can call that particular function a monotonic function. So here it is defined that fa and fb is this, then which of the following is true? Okay, so given that f, see, remember that it's a only one is the correct answer. So if we get the correct one, your job is done, you don't need to check the other one. So f is a strictly monotonic continuous function in, for example, a to b in this interval. So obviously f of a less than a and f of b greater than b. This will has to be followed. and minus f of b will be less than minus b. Now f of a minus f of b similarly will be a minus b, and f of b minus f of a will be greater than b minus a. So if we just divide them, f of b minus f of a by b minus a greater than 1. So with respect to Lagrange's theorem, we can write it that this is nothing but equal to f dash c. Remember that Lagrange's theorem we are applying. So that is fb minus fa by b minus a. And this one is greater than 1 also. So simply f dash c is greater than 1. So then fx is a strictly increasing function. Simply strictly increasing function fx. So only one value of c is possible. Hence fc equal to c exists in this interval. So luckily very first option is correct answer. Okay. Next. Question is, they have given a simple limit and we need to solve it, but it's a dual variable one, x and y 2 to minus 2. Okay, in my explanatory videos you will get all the solutions. So here I am just solving it, x y 2 to minus 2. So this is root over x minus y minus 2, x minus y minus 4. So here limit x tends y. So I'm just not writing all these stuff. So x minus y minus 4. What I have done, I have taken this as a plus and multiplied numerator and denominator. What I have multiplied? This thing, root over x plus minus y plus 2. So at the end you will get a function xy 1 by root over minus y plus 2, because these two have been cancelled out. So just put it the values, root 2 minus of 2, this is outside this, so this one. Answer is 1 by 4. So simply option B is your correct answer. Okay. Next. This one is based on a structure. Okay, they've given as base, this is f of r equal to ln means log e base log r base e, g of r is a function 1 by r. Now they have given us expression, which one will satisfy this particular expression. So here r equal to xi plus yj plus zk. Okay, and r equal to, we know, mod r whole to the power half. So f of r equal to log r, f of r equal to log r equal to log of x square plus y square plus z square whole to the power half. So this thing is happening. So this is half log of x square plus y square plus z square. Okay, now in this case if we proceed further, then we can do it. Then del f del x equal to half into this, so I'm just writing directly x square plus y square plus z square. Del f del y will similarly be y equal to x square plus y square plus z square, and so does del f del z. So now for nabla fx we can write xi this thing, this is r by r square, and g of r will be 1 by x square plus y square plus z square whole to the power half. So here we can do another stuff, that is del g del x. This partial derivative will reach you to minus x divided by x square plus y square plus z square whole to the power 3 by 2, and del g del y is minus y, just the same way we have done the previous one, and so as del g del z. After doing till this level, all we have to do is now to find this value. This will be again similarly like this one. Put it xi plus yj, or this one will be only 3 by 2. So this is r minus r by r cube. So these are the two values we already got. So all you have to do is now 2 into put it in the value f plus h of r and nabla g equal to 0. So 2r by r square plus h of r minus of r square equal to 0. So h of r equal to 2r. Hence the answer is, if you get back to this, answer is simply option number C. Okay. So the main idea is the derivative and putting into the value. Only the notations are relatively tougher, so that is the only reason of confusion. And remember that while viewing this video you can pause. Okay, that will save some time and this will also give you the confidence. Okay, the next sum will be relatively easier one. Okay, this is our next sum. The non-zero value of n for which the differential equation becomes exact. Remember that in order to check it exact, we need to show that del m del y equal to del n del x. So all I have to do is, here m equal to, remember the coefficient of this, so this is m and this is n. Okay, so del m del y, what is del m del y? So this is 6xy plus n square x square. What is del n del x? 3nx square plus 6xy. Now if these two are same, so 6xy plus n square x square equal to 3nx square plus 6xy. So now we can solve this part easily. These two will be cancelled out and n equal to 3. So our option is D in this case. Easier one. Now we are proceeding to another question. This one is also based on calculus. They have given one of the points which lies on the solution curve of the differential equation y minus x dx x plus y with the condition of y0 this. So which of the points will be on this? That's our question. So this is the important expression. So all we have to do is to solve them. Okay. So let's solve it. So this will be y dx minus x dx plus x dy minus y dy equal to 0. So y dx plus x dy, I'm just changing the position, you can see y dy equal to 0. So in the very next line we can write d of xy minus x dx plus y dy equal to 0. If we just integrate this, this will become, after integrating xy minus x square by 2 plus y square by 2, RHS has nothing, so that is C. So now putting x equal to 0 as they have given and y equal to 1. So this will give C equal to half. So just put it over here in this equation. So you will get xy minus x square by 2 plus y square by 2 equal to half. Multiplying both sides by 2, we get our point, that is 2xy minus x square plus y square equal to 1. Okay. Hence, now all we have to do is check these 4 points one after another and which of them satisfies this equation's RHS. and after putting you can see that 2 1 is the only point which satisfies. Hence 2 1 is the answer and C is here the correct option. Next question is question number 10. This question is about closed subset of T and the compact subset of R. Okay, so they have found if S intersection T is not a null set, then S intersection T is what? See, it's a theoretical question. It's now the basic theory. If given that S is a closed subset of R, S equal to closed subset of R, and T is a compact subset of R, and S intersection T is not equal to this. So we know that phi is open as well as closed. So this one is open as well as a closed set as well. So this phi is nothing but a compact set. Hence option C is our correct answer. Now we are proceeding to next question, that is question number 11. So they have given us a series, a big series is given, summation of this 2k minus 1 and this one. So both the series are convergent or divergent, that we need to cross check. So very basic formulas we have to apply in order to solve this question. Let's do it. So in the very first case, the first formula for S, we need to do it. I'm just giving you a hint, I'm not going to solve it. Un by un plus 1 you have to do. Okay, in the very first case. And in the second case also we have to do it in the same way. If you just do it in the very first case, limit n tends to infinity, un plus 1 by un will give you infinity. And in the very second case, if you do it, limit n tends to infinity, un plus 1 by un, this will give you 1. If you are having any confusion, I am just giving you the expression of un plus 1 by un, which will be easier. So see, in this case, so this expression will be 2n minus 1, sorry, this is 3n, so 3n minus 1 by 3n plus 5, n plus 2 by 5, and this divided by 3n minus 4, 3n plus 2, and this is n plus 1 by 5. So in this way, if we just calculate it, this will be cancelled out and we are ending up with 1. So the first sequence is infinite, so this is divergent, and this one has a finite value, so this is convergent. So the first one is divergent here and the second one is convergent, so option C is our correct answer. Okay, if you can't solve it, you just can check it in our study materials. I have solved it there, this entire sum. Okay, if you have any kind of issues, you can also give in the comment segment, so we will obviously get back to you. 13 is coming. Now where is 12? Oh, here it is. So let's see what is given in 12. So it's let an be a sequence of positive real numbers satisfying 4 of an plus 1, this thing. Then all the terms of the sequence lies in which interval? So this is the question they have asked. Okay. So 4, no, I need a darker color, just black. 4 by an plus 1. If we just do it like this, this is given 3 of an cube by 81. So After adding one, an is the answer. So an plus 1 equal to 324 an 3 an to the power 4. Okay, putting n equal to 1, a square will be 324 to 43 plus 1, which is obviously greater than 1, as a1 equal to 1. Okay, so now let a of n plus 1 equal to y and an equal to x. So obviously y equal to what will happen? 324x to 43 plus x to the power 4. So dy dx is 243 plus x4, 324 minus 324x, 4x cube divided by 243 plus x4 whole square. Now for increasing function, we know that dy dx greater than 0. So this one is also greater than 0. So the denominator part will give you so that is minus 3 to 3. So y is increasing when x lies between minus 3 to 3. So limit of an is 1 to 3. Okay, hence if we get back to our option, that option D is the correct answer. Now we have to get back to question number 13. Okay, so largest eigenvalue. So you see that it's a 3 into 3 form. As it's a 3 into 3 form, so there will be three eigenvalues. Okay, we know for eigenvalue we need to subtract lambda from the principal diagonal. There is no direct formula for this, so we have to do it in this way and solve it. So if we just calculate this, we will get 1 minus lambda into 64 minus 20 lambda plus lambda square minus 1. This one is a boring calculation over here. 4 256 plus 60 lambda. How we can solve it? You will get a cubic equation at the end, and that will be like this after just rearranging the terms. And if you solve it, this will become lambda minus 21, and here also you can take common, so this will give you lambda square minus 189. 189 into 21 equal to 396 times. Okay, this trick will be useful. So lambda equal to 21 or plus minus root over 189. According to option, it's B. You can see that it's B is the correct answer. That's all for today, and in the next videos I will discuss the rest of the sums. Thank you.